Okay, welcome back for part 4 of Indicate with me. And here we got a horrible piece of material in the chuck. We've already put a center drill feature in it in a previous video. We've got it in our best live center with the tailstock button down, and in the 3-jaw chuck it goes. And I wasn't particularly careful about how I clamped it up in the 3-jaw chuck. And you may recall what I said earlier about not many of us indicate our 3-jaw chucks, largely because we can't do anything about it. But it's always rather humorous when you slap a part in there and you think, oh yeah, it's concentric, and you start making various cuts, turning and turning the part end for end, and maybe gripping it on the inside, the outside, grabbing different spots along the way of the part, and then you wonder why there's some discrepancy and it's not a perfect part. Well, just because it's in the chuck doesn't mean that it's true in the chuck. So sometimes you need to take another grip at it. Sometimes there's girder debris, and sometimes it's just if it's a piece of used stock, try gripping it in a different spot on the material. Like if there's any wear on it or striations, you can sometimes pick that up by miking the OD of the material and discovering that there's one bad section that you should not be gripping, or select a different piece of material if you can. But a lot of times you can't. You have to use the what's available, what's in front of you. So I took another sort of stab at it, and we've got it at about 2.5, but I'm surprised that it's that bad. I don't know if it's the material of the chuck or both. It doesn't really matter. We'll move right along. So let's identify our objective in all things to do with indicating, and that is to set up the part accurately so as to make a good quality, dimensionally correct part within the tolerance range that is called for in a timely fashion. And that means the least number of moves of the part, the least number of moves of the tool across the part, the least number of setups. So in almost every machine shop, time is money. So that's when I mean timely fashion, I generally mean as quickly as possible. So I'll get into the subject of headstock alignment, tailstock alignment, and steady rest alignment in a different later video. But right now we're just gonna get into the premise of tool path indication or tool path prediction. So here we are at the tailstock end, and there's a little bit of run out there, less than we had at the midsection or near the chuck, so that's fine. Remember, what we ought to do before we sweep our dial here is prove to ourselves that the part is cylindrical. In this case, I'm quite certain that it's within 1 thou on the diameter anywhere. That's fine. We can call that cylindrical. If it was a tapering part, we should create 2 identical test diameters first by turning one diameter, measuring it, and then taking a lighter cut over here, measuring that, and then correcting again, taking a second cut so that these 2 diameters are identical. And when we then want to use a dial indicator to check their relative alignment to one another, we're measuring off 2 similar diameters. That would be how I would approach it, because I think I could do that quicker and more reliably than mathematically subtracting the difference in diameter of the material. I have done that many a time, but again, you just add unnecessarily to the cognitive load and create a possibility for disaster. Just do whatever suits you. If you like numbers, do it mathematically. If you like the no math version, spin some identical diameter test diameters on there. And wherever you're doing this along the length of the bar should be approximately where you're going to be doing your turning. Don't bother doing all the indicating down here if you're going to be turning in a 3-inch zone here, and vice versa. So if you're going to be turning just in the midsection of the bar, do this indication there. The more in alignment your machine is, the less it matters where you're doing that. Okay, we've got a tool in here so we can imagine what we're going to be doing here more readily. You can do the indicating to prove your setup or predict with or without the tool. It makes no difference. If we're going to be doing any cutting with that tool, I would highly recommend proving that it is at the center line height. So we have a tool here that is the distance from the bed to the top of the tool is center line of the spindle. So we can swing that over here and prove that our tool is on center line height. And we can then also use that as a reference to set up an indicator. So before we set our indicator up, however, if we come into the work and touch at 0 and of course move over, if we were to then infeed and then engage the carriage power feed, you know, with the part rotating, of course, we would be taking a cut, we would be removing material. If we were to touch off and stay at 0 and engage the power feed, hopefully we'd be removing no material, we'd be taking a dust cut. If we back the tool off any amount, 100 thou, let's just say for argument's sake, and we engage the power feed, or we manipulate the hand wheel for that matter, all three of those paths are parallel to one another. So if we indicate out here and see how the tool would react to the part, we can predict how it's going to behave when we're actually taking a cut. So we then have our dial indicator that we're going to set as close as we can to the center line height of the material. We can, however we choose to do it, we can get that dial to set it at 0. And just so that we know we haven't bumped any dials, we'll set the DRO to 0 so that if we accidentally touch that carriage in feed, all is not lost. And if we then move the carriage along the length of the bedway and we observe the dial indicator, this will indicate how our tool would be interacting with the part. In essence, a tool path predictor. In this case, we're getting very little motion on that dial sorry about that. We're getting that dial isn't particularly, you know, trending up nor down. It's tracking across the part quite nicely. And someday I'll get a tripod for you guys, but until then you'll just have to take your seasickness pills. So this means that our projected cut path is parallel with this edge of the material. So the material being cylindrical now, we take a cut, it'll be cylindrical when we're done. And that is the objective, is to create a cylindrical part. So that is a win. If we are moving the carriage along and this were to be, that dial were to be increasing or decreasing as we moved up or down the part, that would indicate to us that this part is not aligned to the long axis of the bed and or the projected tool path. So that's how we can predict the outcome of a cut relatively quickly and easily on the lathe.